Sample exam 1, problem number 1. We're going to try to solve this system here using the process of elimination by addition. So let's get started. How about if we try this? Why don't we eliminate y, and that will get us x. And then when we do this, we'll come back and eliminate x and get y. So focus in on the y's. We want these numbers to be opposites. They're already opposite signs, so let's get them to be opposites by multiplying this by 2, this by 3, right? What's the smallest number both 6 and 4 divide into? It's 12. We can make this a 12 by multiplying by 2, this a 12 by multiplying by 3. So here's what that's going to look like. We're going to take 2 times equation 1 plus 3 times equation 2, and that's going to look like this. So multiply through the top equation here by 2. We'll just double everything. And that will give us 10x minus 12y equals 4. And then in the second equation here, right, we're going to multiply by 3. So multiply through this equation by 3, and that will give us 12x plus 12y equals 9, right, multiplying by 3. Let's add these together. 10x and 12x, we'll get a 22x, and then negative 12y plus 12y, that's 0, so that goes out, and then we'll get the 4 plus 9, which is 13, and then we'll divide both sides by that 22, so we will get x equals 13 over 22. I'll circle that so we don't lose it. And now, let's eliminate x and get y. So what we're going to do here is we're going to focus in on the x's and get these to be opposites. So the smallest number both 5 and 4 divide into is a 20, so we're going to make them 20s, but they have the same sign, so we need a negative multiplier. How about if we multiply the top equation by negative 4? So this is going to be negative 4 times equation 1 plus now 5 times equation 2 will get us a 20 there. Let's see what it looks like. So multiply equation 1 by negative 4. So everything in here, that top equation gets multiplied by negative 4. So how about negative 20x plus 24y equals negative 8, right? Multiplying everything here by negative 4. And then the bottom equation, the second equation, we're going to multiply by 5. So this will give us 20x plus 20y equals 15. We'll add those together. The x's will go out, right? They're opposites. And we will get 44y equals negative 8, and 15 is a 7. Let's divide by 44. So we'll get y equals 7 over 44. And then let's just summarize our results here. We'll get x equals 13 over 22. Y is equal to 7 over 44. Now, in problem number 2, we're going to solve this system. And I think we have an idea of what's going on already, right? Because take a look at these equations here. The second equation compared to the first. Okay, double, double, not double. So if you remember what we said about those, that's going to be no solution, right? Double, double, not double. Or we could triple, triple, not triple. But this is going to result in no solution. But let's try it to see what happens here. See why there's no solution. So what we're going to do is we're going to eliminate y and get x. So to eliminate y, we'll focus in on these y's, make them opposites. The smallest number they both divide into is 14. Let's multiply this by negative 2. So the plan is negative 2 times equation 1 plus, now we don't have to do anything to equation 2, right? Because equation 2, we already have a 14. So let's try this. Let's take this negative 2 and multiply it all the way through equation 1. So just get, what, negative 4x minus 14y equals positive 6, right? Let me just check that. 2 times negative 2 is negative 4. 7 times negative 2 is negative 14. Negative 3 times negative 2 is 6. Write down the second equation, no change there. 4x plus 14y equals 3. And when we add these together, the x's are gone, the y's are gone, and we end up with this statement here that 0 is equal to 9. which of course is false. And that means that these two lines are parallel. So we have that line 1 is parallel to line 2, and what that means for us is no solution. But that's what we expected to begin with. Now, here in problem number 3, look at the second equation compared to the first. Triple, triple, triple. So back in problem 2, we doubled, did not double, and now we're going to triple everything. Triple, triple, triple. So we remember what this is, right? This is no unique solution. But let's see what would happen if we were not to recognize that and we try our traditional approach where we eliminate y and get x. So we focus in on the coefficients of y. The smallest number they both divide into is 3. They have the same sign, so we need a negative multiplier. So how about if we multiply top equation by negative 3? So let's say that we're going to take negative 3, multiply that through equation 1, and then add equation 2. So doing so gives us negative 6x minus 3y equals negative 12. No change in the second equation, just 6x plus 3y equals positive 12. Adding these together, the x's are gone, the y's are gone, right? They add to 0, and negative 12 plus 12 is 0. So we end up here with 0 equals 0, which is a true statement. And that what means, in terms of our lines, we have coincident lines, which means no unique solution. Okay, now that's good, but now we have to go a little bit further. What we want to do is see what these solutions look like, right? There's no unique solution. There's infinitely many because the lines coincide, so there's infinitely many points of intersection. So let's see what these solutions would look like. Let's come up here to equation 1 and solve this for y. So here's the plan. It's easy to solve for y in the sense that I don't get any fractions. So solve equation 1 for y. So we'll subtract 2x. We'll get y equals negative 2x plus 4. And now we have infinitely many choices for x. If x is 0, y would be 4. If x is 1, we get negative 2 plus 4 is 2. So there's infinitely many choices here. So what we're going to do is we're going to say that by x is equal to, now we could write any number, but we're going to use t to represent any number we like. Then if x is t, right, if x is t, we put that in here and we'll get y. So y is equal to negative 2t plus 4. So that's what these solutions look like, where t is any number you choose, then that's going to be your x value, and then you substitute that t in here, and that'll give you the corresponding y value. Here in problem 4, what we want to do is we want to write a second equation here so that in part A, what we have is, in A, we're going to have no solution. So we can get no solution, right, if we do this. If we say double, double, don't double, or triple, triple, don't triple, just pick a multiple. 2, 3, 4, anything. Negative 5, negative 6, negative 7. Multiply it on this side, but don't multiply it on this side. So here's one possibility. If I just keep it simple and double, we could get this. 16x minus 4y. Now just don't double any number here except 10. How about if we just write a 1? Okay, there'd be no solution for this one. And in part B, what we want is no unique solution. So to get no unique solution, we know what to do here. We are going to pick a multiple, like 2, 3, 4, negative 5, negative 6, whatever. Multiply it all the way through. So why don't we could double. We doubled last time. Why don't we just triple? So to triple, what we're going to get, this one is going to look like this. Just triple all these numbers here, right? 24, negative 6, 15. So we could write, I'm going to triple, so I'm going to get 24x minus 6y equals 15. Problem number 5, we're given this system here, and we're told that it converts to this row-reduced echelon form, but let's see how we're going to get that. So the row-reduced echelon form in this case is going to be, well, it's going to be 1 and then zeros below, 0, 1, 0, 1 on that main diagonal, 0's elsewhere, 0, 0, 1, and then we're given that the right-hand column is -3, 0, and 1. So what this is telling us now is that 1x, no y's and no z's, is -3, right? So an x is -3. So we can write here that x is -3, and similarly, no x's, 1y, and no z's is 0. So 1y is 0. So we can write that one. So y is equal to 0. And then finally for the third one, no x's, no y's, but 1 z is equal to 1. So z is equal to 1. So we can write that. Z is equal to 1. So the nice thing about this row-reduced echelon form is that it just makes the solutions pop right out for us.